For quadratic 1, the highest species in this area is species St. Augustine grass, with the total number of individuals is 105. Next is species Chrysopogon aciculatus, followed by Grona triflora, Chromolena odorata, and the least species is Mimosa pudica, with the total number of individuals is 2.
For quadrat 2, the highest species in this area is species Xenopus compressus, with the total number of individuals is 27. Next is species Dicranopteris linearis, followed by species A, species Pteria spicellata, species B, and the least species is Litzia glutinosa, with the total number of individuals is 2.
Quadrat 3, the highest species in this area is species Augustine grass, with total number of species 91. Second highest are Chrysopogon aciculatus, followed by Grona triflora, and the least species in this area is species A, with total number of species are 3.
Silau le. Apa dia tak detect macam tu?
Commensalism is a relationship between individuals of two species in which one species obtains food or other benefits from the other without harming or benefiting the latter. The species that benefits from the association may obtain nutrients, shelter, support or locomotion from the host species. The interaction has little effect on the host organism, whereas the commensal species may exhibit significant morphological adaptation. Commensalism can be seen in the interaction of fern and tree. Although ferns grow on top of other trees, they do not steal nutrients or water from their hosts. Ferns have structural adaptations to dry environments. These adaptations include hard tissues, a very thick cuticle on the epidermis, and plant hairs on the leaf and stem surface. Parasitism is defined as a two-species relationship in which one organism, parasite, lives on or within the other organism, host, causing some degree of harm to the host. A parasite reduces the fitness of its host while increasing its own fitness, usually by gaining food and shelter. The parasite is the species that benefits, while the host is the species that is harmed. The interaction of parasitic fungi and trees demonstrate parasitism. Parasitic fungi feed on the tree and may eventually kill it. Parasitic fungi not only absorb essential nutrients, but they can also gradually replace host tissues with their own. When living organisms require the same limited resources to thrive in their shared environment, competition occurs. Competition can occur within a species as well as between species. Intraspecific competition occurs when members of the same species compete directly, whereas interspecific competition occurs when members of different species compete for the same thing, such as food, shelter, and water. Competition frequently drives adaptation. Many traits, characteristics, and competitive behaviors have evolved to ensure the species' survival. Competition can be seen between the plants. Plants compete for the light by growing quickly to reach it and shade other plants with their leaves.
Based on our findings on this field trip, we can show that prey defense is one type of interaction between organisms used by animals. All animal life depends on defense mechanisms. Prey animals must continuously avoid being eaten because all species is every biome defense on food to thrive. Animals use adaptations to increase their chances of remaining alive as a species. The survival of organisms at low and intermediate trophic levels is primarily influenced by predation and resource competition. It resembles a battle over how predators and prey interact. There are several common defense systems that will be covered in this discussion, including alarm call, flashing, coloration, cryptic coloration, and chemical defense. Alarm call meaning is any loud noise made during a predator or prey encounter, regardless of the stage. Many species of mammals and birds make these cries when they encounter predators, and they can serve to warn nearby conspecifics of the threat and trigger the necessary escape reactions in them, improving their chances of survival. Cicadas utilize their songs to attract partners, engage in countering, and scare off any predators. There are notable variances between the frequency and temporal patterns of species that coexist in the same habitat, and each species in their own calling songs. Flashing coloration is the ability to hide oneself in one of the biggest obstacles for moving prey. When prey is moving, color patterns cause predators to experience optical illusions, making the prey difficult to catch. From this experiment, we can classify that Boiga dendrophila under flashing coloration. Locally, the pattern components of striped prey that travel across a predator's area of vision switch between bright and dark. The predator's ability to resolve the maximum frequency of the prey's alternations, known as the temporal frequency, will be exceeded if the prey travels quickly enough, causing the stripes to be and eventually disappear. On the other hand, a defense mechanism or strategy used by organisms to hide their appearance, often to blend in with their environment, is called cryptic coloring. Organisms conceal their location, identity, and movement through cryptic coloring. An example of cryptic coloration that we found at observation area is Phrynoides juxtaspera. Their brownish-gray lumpy warty skin is like their rocky streams and riverbed habitats, making it difficult for predators to see them. chemical defense is prey use defensive compounds to lessen the risk of being eaten. These compounds include unpleasant, offensive-smelling, difficult to digest, poisonous or venomous substances that discourage, frighten away, hurt or distract predators or prevent them from being seen. Defensive chemicals can also include substances that, when released, alert nearby conspecifics to the presence of a predator. Trigonellus corallinus have the capacity to synthesize a variety of defensive chemical compounds to fend off predators.